Hi there. In this video, I'm gonna discuss with you more examples about how to find the limits. Let me talk about this first question. Wanted to find the limit when x approaches to minus 3 for x plus 3 over x squared plus x minus 6. If we try to make substitution directly about x minus 3 here, this will be 9, here will be minus 3, and here's minus 6. So 9 minus 3 minus 6, that's mean 0. So we will fail to find the limit if we do the substitute directly. So we need to make change in the shape of this function first by trying to factorize this. This can be factorized as x. Here we can see in the solution here, x squared plus x minus 6 can be factorized x plus 3 times x minus 2, because x squared will be written x and x, and 6 can be factorized into 3 and 2, and because the sign here is negative, we put different signs here, and we give the bigger number the sign of the middle. The middle is positive, here is positive. Okay, after we make the factorizing, we see we can make cancellation, this with this. Here stay 1, here, and the bottom stay x minus 2. Despite the shape of the function is changed, should be the domain still the same, no changed. Okay, now we make the substitution. Then the limit will be, when you make the substitution in the new form, the limit will be, just make a substitution about x equal to minus 3 here. It will be 1 over minus 3 minus 2 will be 1 over minus 5. So the limit is 1 over minus 5. Okay, this is the first equation. Let us talk about another question here. Find the limit for x approaches to 4 for the function absolute value of x minus 4 over x minus 4. If we also try to make the direct substitution about x here, we will find the bottom is 0. So we will fail to find the function in this shape. So we need to make a change in it. First, let us try to define the absolute value here without the absolute symbol. We know the absolute value can be written in two shapes. Here, absolute value for x minus 4 can be written x minus 4 when this is positive or 0, or we just put minus in front of all this quantity when it is negative. I mean when it's less than 0. To make sure negative times negative, it will be positive. So always the absolute value will not be negative. So the two shapes of the absolute value, then they are here. The first one when x is greater than 4, because we move negative 4 here to the other side, will be positive. So x is greater than or equal 0, or equal 4, I mean. And here, when we move this on the other side, it will be x less than 4. So these two shapes instead of the absolute value. Now we start to find the limit by dealing with each equation. The first equation, we put it instead of the absolute value here. So we will put x minus 4 instead of the absolute value. And the bottom is still same. This because x approaches 4 from right of 4. From right, that means from values bigger than 4. So as bigger than 4, so that's why we got this for or this equation and put it instead of the absolute value here. And the bottom is still same. So now they became the same, so we can make cancellation. To cancel those together, 1 will stay here and 1 will stay here. So 1 over 1, that's mean 1. So all the question change into like find the limit for the constant number 1 when x tends to 4 from right, which is will be 1 because the constant is still the same limit. And again we repeat that with dealing with when x tends to 4 from left of 4, I mean from values less than 4. That's why we'll take this equation and put it instead of the absolute value. Instead of absolute value here, we will put this form. So the equation will start to be by this shape. Here we put that instead of the absolute value. And this stay the same. Now also we can make cancellation. When you cancel this together, will stay minus 1 in the numerator and this will stay here 1. So minus 1 over 1, it will give me negative 1 or minus 1. So the limit for minus 1 when x tends to 4 from left, it will be same number, which is minus 1. Now comparing these two limits from right and from left, we will find they are different. As they're different, we say there is no limit for this function at x tends to 4. So we write here no limit or the limit not exists. Okay, this the second equation. Let us see the third equation. Third equation here, we need to find the limit when t tends to 25 for this function. When you also try to make direct substitution in the bottom here about t by 25, it will be 25 under square root. That means it will be 5. So 5 minus 5, it will be 0. That means the bottom here will be 0. So we will fail to get a limit for this function when it's still in the same shape here. So we need to make a change in it. The change we will do, we will consider this as square for 5, and this is square for here the square root of t. This square for square root of t because we can consider it as square root of t times square root of t will be same as t. That's why we can consider this as squared for this together by multiplying each together to give t. So now we can consider this as difference between two squared, and we will make factorizing. To factorize this, two brackets and another two brackets, and the signs negative and positive. Here 25, well, we put it 5 and 5, and this, as we explained here, will be square root of t and square root of t. Now we compare the bottom and the numerator. We will find this factor, it's the same like the first factor here. So we can cancel them together. By cancelling those together, this will remain and the bottom will be 1. So the answer will be here is the new shape for the function after the cancellation. And we confirm also the same domain will be for the same new shape as the same domain for the original function. Now we can make substitution. We say limit when t approaches to 25. Here we'll make substitution about t by 25. It will be 5 plus square root of 25. Give me this here, which means 5 plus 5, that means 10. This is the limit for this function. Finally, we'll give this example. This example for the limit of this function when h tends to 0 or approaches to 0. Also here, when we substitute about h by 0, the bottom will be 0. That means we fail to find the limit for this function in this shape. So we need to make a change in it before make the substitution. What the change we can do? Here, when you look for these two brackets, here is a square. And though this also 16 is a square for number 4. So we can make factorizing for those like difference between two squared. Factorizing for it can be written like here, square can be written h minus 4, h minus 4. Because when we multiply those together, will give me h minus 4 squared. And 16 will be written 4 and 4. Because when we multiply 4 and 4, will give me 16. And the signs also are different, positive and negative. Those two signs. We do that always when we make factorizing for difference between two squared. Then we simplify this by removing the brackets here. It will be h minus 4. Remove this, will not affect minus 4 here. And also remove these brackets. And after then we make cancellation. Minus 4, that means minus 8, h minus 8. But here the cancellation was happen because here it will give me 0. Minus 4 plus 4 equals 0. So still here only h. Now we can make cancellation between h here and h here, and stay h minus 4 is the result. H minus 8. H minus 8 is the result. And this is the simple form of the function here. And still have the same domain of this function. This function, the domain is r without 0 because h is 0. It's the same here, will be r without 0. Now we make the substitute about h to find the limit when h tends to 0. When h tends to 0 here. F of h when h tends to 0, and here also h. No x in this question. Okay. Limit for f of h when h tends to 0 is equal to limit h minus 8 when h tends to 0. Make substitute about h by 0. So still 0 minus 8, that means minus 8. Then the limit is the negative 8 is the last answer for this question. Okay, and that's it for this video. Hopefully we'll see you again in the other next video. Thank you for watching. See you again. Bye bye.